So I want to talk about the benefits of protocol-oriented programming. You can see here that I've got a test case that involves 5 steps. If we look at step 1, you can see that we're signing up a user which needs some credentials and a first name. So the credentials is username, password, and then there's some additional stuff on the submission form like first name, and we submit that to the sign up service. If we take a quick look at the sign up service, you can see that it conforms to a protocol called decodable endpoint executor, and this protocol demands that you implement these functions. Now if we first take a look at endpoint executor, this is another protocol here, and if you conform to this, then there's only one function. Quite simply, contact the server and get some sort of response. But if you also want to decode something from the body of the response, then there's this protocol here where you say the content that I'm decoding needs to conform to the decodable protocol in order to be suitable. Now if we look back down here at the service, you can see that we implement instruct server and we specify that the response should be an XCT HTTP response. This is a response that comes from the testing framework, and then we go into contacting the server using this testing API. But you also notice that we don't have resolve in here. And there's another example here, another service where we're doing the same thing, but we also don't have resolve here either. And the reason for that, if we pop back here, if I delve into resolve, you'll see that we have an extension on the protocol that says if we're in a testing environment, denoted by the fact that we're constraining the type and saying that if it is this testing value, then we'll do something custom. We're going to have resolve, fetch the response, aggressively assert on the code in the response, and then try and decode something from the body. And we're implementing decode response, and we're saying that if you attempt to decode using this decodable type and you don't find anything, then I want to call into the testing framework and conveniently throw if it's nil. So then this line here will throw if we don't get this type, export user from the response. Or before that, if the HTTP status code is unsuitable. All of that is captured in this single line, and then we call it here, and because we're in a throwing test case, denoted by the throws here, the test case will capture all of that. So it's quite convenient having that protocol. It means that we can move forward with a concrete type, and we don't have to deal with optionals or any checks, because all of that is going to be handled for us. If we look at the next step, you can see that we're doing something very similar, and we're getting a token from the response. The next step, we're doing something similar again. The room name is inspired by what's currently in front of me. And the next step, you can see we have a leave service, and we're just calling directly now instruct server, and we're asserting on it here just because we can. And the next step then is to confirm that the room is no longer there, so we capture the error here, not found. So okay, that's great. These protocols are quite useful, but you can see there's still quite a lot of code here, and you could move these functions out and put them at the bottom of the class or in some sort of user sign up factory, for example, and it's perfectly valid to do that. You could put them in the superclass, but then the superclass will get quite busy and you've got the diamond inheritance problem to deal with. So it would be better if we had some sort of protocol. Again, so if we were to look at one that I prepared earlier, called user generator, if we pop into this protocol, you'll see that I'm specifying that you must have an application to hand. So I'm designing these protocols with the intention of using on a test case, and a test case has an application at hand. And then I'm extending the protocol to say, here are some convenience functions then that you are going to get by conforming to this protocol. So you can sign up with credentials, password, username, and so on. So now if we look down here, we can sign up with credentials. So that's quite useful. If we look at create room, we can put on another protocol called the room generator. And then that's going to be a room, and it accepts a token. Okay, that's quite handy. We no longer need this one. Then there's remove user. We have another protocol, room ejector, for that one. And try await user ID from room. Okay. And what does that return? It can return the response, or there's another one here as well. Okay, so and now we don't need this, so that's handy. We don't need the, oh, that's the next step. So if we look at the next step now and we want to fetch the room, then we've got a room fetcher for that. Room fetcher, fetch room ID or value token. So we can do that. We can actually say, if we say that we want the room, then it will do the enforcement for us. And now we can put fail there. Okay, this needs a string. So that's cool. We don't need that service anymore. So that's good. It's a little bit more concise, but there's also some additional things we can do. We can say that if we are both an authenticator and a room fetcher, then we can combine some steps together. So an authenticator will create an account for us, generate account. It doesn't need credentials, and we don't need to log in. Right, so that's the power of the authenticator. It combines both the sign up service and login service together, and then generates an authenticated account for us. So that's nice. But also, we don't need credentials, and we don't need to do the login step. Token is here, and the user is here. Okay, that's good. But if we're both an authenticator and something else, right? So if we look at not room ejector, room fetcher, you'll see that we have a constraint that says if we are both an authenticator and a room fetcher, then generate a token for me and then pass that token on. So now that we're both of those things, I can generate a room without a token. I can fetch a room without a token, right? And I don't particularly want to do that in this test case because that involves creating additional users just for the sake of querying something, and that's inefficient. If I've already got a user to hand, then I'll just pass the token on. But there are other cases where that's quite useful. So you can see now it's a lot smaller, a lot more concise, and the power that we've got by just bolting on this functionality and combining this functionality together makes it very useful for a lot of the test cases that I've got. And I've got quite a few. You can see leave room tests, and generating account, generating a room. There's a bunch of functionality bolted onto this, so it's quite convenient now. This repetitive nature is now put into these protocols, so it's quite cool.